The focus is energy related. We have examples which are from the important areas of wind energy and hydrogen, and one for production optimization, with which we are going to start. Therefore, I welcome Josef Nagl, who is Product Management and Sales for Digital Products at Phil. The title of his presentation is Data-Driven Technologies in the Production System. Mr. Nagl, the stage is yours.
Okay, thank you. Hello everyone, welcome from my side here at the LightCon in Hanover. My name is Josef Nagl and I work as a product manager at Phil. Today I have the pleasure of giving you a short presentation why it is useful to use data-driven technologies in the production system. First, I want to show you the agenda of my presentation. So, I will say something about the company Phil, then I will say something about the 5 pillars of digitization at Phil, and then I will talk you something about Cybernetics Produce, Cybernetics Studio, and Cybernetics Analyze. Oh. Let me give you a brief overview of the company Phil. The company Phil was founded in 1966 by Josef Phil, together with 1 employee. Today, the company counts over 950 experts with a turnover over 170 million euros. The company is 100% family-owned, and it has a comprehensive portfolio ranging from woodworking machine and machines for the industrial composite production to metalworking machines. A big part of the turnover is made with machines specially fit for the customers' requirements, but also at the moment with digital products. Under digital products, we understand data-driven technologies like IoT. I mean, big data, IoT, machine learning, and AI is in everyone's lips at the moment. I want to show you what is the main point behind data-driven technologies and why it is important to improve, to digitalize your production system. Machine learning algorithms enables a system to learn and improve from experience without being explicitly programmed. Data scientists or machine learning engineers develop algorithms which access data and use it to learn patterns from this data with different optimization strategies. To enable the algorithm to learn, it's important to identify the relevant parameters and so-called features, and to prepare them in a meaningful way, so the algorithm can extract the necessary information and learn the patterns. For this, to be able to understand our machines and optimize your production system, it is necessary to get a lot of information and data to learn your algorithms. All this together combined is digitization as we understand it at Phil. Therefore, we have 5 pillars of digitization. The first pillar is Cybernetics Produce. This tool is a tool to collect all process data of the whole complex automated line. Normally, our customers use it, for example, for a traceability system. And it's a tool to optimize your process in the automated line. With Cybernetics Produce, you can guarantee the same process every time for every part. The second pillar we have is Cybernetics Studio. Cybernetics Studio is our operating system for a tool for highly complex process, like we use it for the Accubot, and there we have, for example, a non-destructive testing process, like X-ray or ultrasonic systems. It also includes an offline programming tool, so your downtime of the machine is minimized. The third pillar we are having is Cybernetics Analyze. Here we are talking not about process data, here we are talking about machine data. Therefore, we are collecting machine data in a highly frequency and so we check if there are anomalies during the process. Some other themes like predictive maintenance can there be included. With Cybernetics Analyze, we can also offer some business cases. For example, we can sell a machine with a business case like we want to sell it with pay-per-use or something like this. Also very important for your process is to get some eyes into the machine. So we have a Cybernetics Vision. It doesn't matter if it is a 2D position control or a type identification, or is it a higher complex 3D part reconstruction. Vision data are very important to guarantee the same process at every time. And the last pillar we are having at Phil is Cybernetics Simulation. Simulation is a very important part of digitization. For this, we can simulate the complex process of a highly automated line and can check the cycle time or the process in the early stages of development. Also, we can simulate some part processes before we are building the machine, and so we have the guarantee of a functional machine before we are building it. Now I want to go a little bit deeper in Cybernetics Produce, Cybernetics Studio, and Cybernetics Analyze. Cybernetics Produce. As I also said in the introduction, offers you the possibility to access all process data directly from the plant. So if you have a bigger plant and a whole automated line, you will have a lot of PLCs controls in this plant. And with Cybernetics Produce, you can get with standardized interfaces all process data of this part. So you always know when your part was, in which time, with which parameters you have produced this part. A typical traceability system. On big lines, it is useful to have a reworking station. So if you have a part which is not good, it is always very comfortable to put this part out with an output conveyor, go to a rework station, then you can identify this part, and the operator will see then where is the NEO part of this part, and he can rework this part, and then after reworking, he can put it back to the machine, and the machine knows exactly what he has to do with this part, and you don't have any waste for this. Also, a very important data is the input material. You only can guarantee a constant process if you know everything about the input material. If you have a batch number or something like this, or the material supplier you are having here, because there are some difference in the material can extend to other problems in the machines. And all this data must be visualized on a big screens or on web interfaces where the operator can see what is going on in the machine. It is very important that the operator sees which part is where, which were the process data, and of course, it is useful to have individual analysis on this screen where you see the bottleneck of the machine. For example, if you have a welding area and you have to see which welding number is the welding number you have problems. The whole thing includes Cybernetics Produce or process data analysis. Let's talk about something, Cybernetics Studio. Cybernetics Studio is our software for complex process and complex machines. We use it in the Akkubot at the field product, and it includes all applications and functions, all this included into one software. So you have the same visualization for every process. It doesn't matter, is it an ultrasonic process or X-ray process, you have always the same interface. You don't have 5 or 7 different software tools. You can only with Cybernetics Studio, you can operate with the machines. It is also kinematic independent. This means it doesn't matter which PLC or which robot you are having on the kinematic, on the mechanical side. It doesn't matter. With Cybernetics Studio, you only operate with this tool. And of course, the complex parts and complex process is time consuming to teach. You can imagine if you have 2 robots which are synchronized and you are testing a big part of an airplane, for example, it will be very time consuming. And with the offline programming processor or with the offline programming tool, you can make the program of this tool directly when the machine is running, and after the process, you put the new program into the machine, and you can test the next part. And of course, it also has a digital twin. You see it here in the first picture. You always see what the machine is doing at the moment. This is, for example, another overview for you. I hope it's clear for you. You see here on the left side, what was this? You see it here on the left side, all applications which we are including with Cybernetics Studio. And on the right side, the kinematics, and it doesn't matter which one. The operating software is only Phil Studio or Cybernetics Studio. And it's always the same operation for the customer. So, and the last one I want to tell you something about it is Cybernetics Analyze. Cybernetics Analyze, we are talking not about process data, we are talking here about machining data. There's a difference in the data between these 2 parts. Cybernetics Analyze, what is this? There we collect machine data directly from the machine during the machining process. The machine data is getting fetched from the machine via several data channels and transferred to a so-called edge device. The edge device is only an industrial PC, which is directly put in the control cabinet. And once the data received in the edge device, it must be processed in real time, because you really want to know during the processing, is your process okay or is it not okay? And to meet the requirement of real-time processing, a so-called data bus should be installed on the edge device. And this data bus is responsible to distribute all the incoming data to all kinds of internal subsystems. One of these subsystems are the control loops for the processing data. And therefore, we are having 2 control loops. The first one is the internal control loop. And the internal control loop is intended for time-critical analysis, which must provide results with a very short time range. This means if you need directly after machining this part, the answer is it a good part or a not good part, so we have always used the internal control loop. To meet this requirement to the internal control loop, constantly processing the data and calculating the results is necessary. For other analyses, for example, we can also go the way to the cloud. For this analysis, we have to collect data from the streams that getting encrypted and transferred to the Phil data cloud on a secure way. This enables an outer control loop across all machines in the whole world, or doesn't matter where you have this machine. So you can look what the machine is doing in Europe, and you can look what this machine is doing in Asia, for example. This control loop is the basis for future evaluations, like predictive maintenance or something like this. You can also use the optional control loop if the resources on the edge device are no longer sufficient and more calculated power is needed. Okay, this is the end of my presentation. I hope this gave you an impression what is the difference between process data, what is the difference between machine data, and why it is useful and helpful to have a very good operating software. If you have any questions, let me know. And we are here at the LightCon trade under here. Thank you.
Yes, of course. So questions from the audience?
Perfect.
Seems to be nothing at the moment. I would have a question related to the software use. How is it when you have a process where other machines from other suppliers are combined with yours? What about the compatibility of your software then?
The compatibility is only the interface. It doesn't matter which is the supplier. We normally use the OPC UA to get this data from the other PLCs. And it's only about talking to the other what data we need. And then we can integrate, of course, other machines. But only for process data analysis, not for machining data analysis, because there you must really know how the machine is working. So what is really the thing in the machine, and this only can make the machine builder. So
okay, because it's important to look at entire value chains, starting with the raw material, maybe ending with recycling, and all steps shall be digitalized. So therefore, it's important that also there's possible to have an exchange and a connection.
Yeah. But we have this option, yes, of course.
Perfect. Yeah. So further questions. So the presentation was so perfect. Yeah, no questions. So therefore, thank you very much, and
welcome.
Thank you very much to Phil for being here for many years and.